Welcome to the deep dive. You send us the sources, and we give you the shortcut. Today, we are looking at a huge body of research on a topic that it's moved faster than almost anything else in health science recently. Fasting, specifically intermittent fasting, or IF. For so long, this was, kind of on the fringe, just another diet fad. But now, our stack of sources, we're talking recent clinical reviews, studies from PubMed, it shows that it's really become a central focus of metabolic research. So our mission today is pretty simple. We want to separate the proven, repeatable health benefits from all the hype around longevity. And the scientific focus here is it's genuinely explosive. I looked this up on PubMed. If you search for fasting health benefits back in 2017, you get about 111 publications. By 2023, that number more than doubled to 234. And this year, we're already over 300. It's clear researchers are finding something real here.
That volume is absolutely critical. It shows the field is moving beyond just simple observation and really digging into the mechanism. So, to guide you through this, let's just clarify the language the research uses because it's important. When we talk about fasting, we're mainly looking at two different strategies. First, you've got intermittent fasting, or IF. That means cyclical eating, so periods of 0 or very few calories. This can range from, say, 12 hours up to several days.
Like the 16.8 or 5.2 methods people talk about.
Exactly. We'll get into those details later. And that's different from the other concept, which is caloric restriction, or CR. That's simpler. It just means consistently eating less every day. So cutting maybe 10 to 40% of your total calories, but you're not skipping meals entirely.
Okay, so one is about when you eat, and the other is just about how much.
Precisely. And what links them is this core idea you hear about a lot, the metabolic switch.
Right, the metabolic switch. Let's dig into that because it's often described as just, shifting from burning sugar to burning fat. But why is that switch so important biologically? What's actually happening?
That is the perfect question. Because the fuel swap itself, that's just the start. The real importance of the metabolic switch is that it acts as a kind of mild distress signal for your body. See, once you use up all the stored sugar in your liver, which takes about 12 to 14 hours for most people, your body shifts gears. And that shift triggers these ancient protective mechanisms inside your cells.
So we have a protective state, not a starvation state.
Exactly. And the main insight here is that this state activates a process called autophagy.
Autophagy.
Think of it like a deep, scheduled cellular cleanup. The cell starts recycling damaged parts, clearing out old junk proteins, just generally making itself more efficient. This is the process researchers believe is behind the anti-aging and longevity potential we see in all the animal studies. It's not just that you're burning fat, it's that you're forcing your cells to clean house.
That reframes the whole conversation. It's a tool for cellular optimization, not just a diet for weight loss. Okay, so let's unpack the evidence. We know the animal data is the bedrock here. Where does the strongest evidence come from? What are some of the surprising results?
Well, the evidence is, without a doubt, strongest and most consistent in animal models, specifically mice and primates. They've given us just compelling evidence for longevity and disease prevention. Take mice. You put them on a regimen like intermittent fasting. Maybe they fast 1 or 2 days a week, or time-restricted feeding where they eat in a specific window. And you consistently see a longer lifespan, better metabolic health, lower inflammation. Their insulin sensitivity improves dramatically.
And I remember seeing one study that was particularly fascinating, suggesting that the timing was doing all the work, even without cutting calories.
Absolutely. That's a key piece of research. It showed that in male mice, daily fasting improved their health and survival, even when their total calories and what they ate was identical to the control group.
So just by changing the clock?
Just by compressing the eating window, it sent a powerful biological signal all on its own.
Incredible. So if that's mice, what about primates? Monkeys are obviously much closer to us, and some of those studies have been running for decades.
Right. The primate studies mostly looked at long-term caloric restrictions, CR gaze. So cutting their calories by about 20 or 30% over many, many years. And the results there are also really significant. Lower risk of diabetes, lower risk of cancer, better heart health, just better health across the board.
But what about living longer? Was that as clear?
That's where it gets a little nuanced. Some studies did show a clear extension of their lifespan. Others just showed better health during their normal lifespan. So healthier, but not necessarily longer living.
So the health benefits are consistent, but the longevity part is a bit more complex. Now, if this animal evidence is so compelling, why do we have to be so cautious with the human data? Is it really just because we live longer?
It's a combination of things. And that nuance is, why we do these deep dives. The main issue is time, like you said. A human lives 80 years. You can't run a controlled 30-year fasting trial. It's just not feasible.
Logistically impossible.
Right. But the other kind of hidden factor is compliance. You can force a lab mouse to fast for 16 hours. You absolutely cannot do that reliably with a human for decades. Human trials have dropouts, people misreport what they ate. I mean, life gets in the way. Jobs, family, social events. So our human data is excellent for short-term metabolic markers, but it's very thin on that long-term longevity proof.
That makes a lot of sense. So given those challenges, let's talk about the human wins. What benefits are actually proven in humans right now in the short to medium term?
We have very, very solid human evidence for metabolic wins. This includes repeatable results in weight loss and, importantly, the loss of that harmful visceral fat around your organs.
Mm-hmm.
We also see better blood sugar control, lower markers of systemic inflammation, and better cholesterol profiles. Basically, your whole metabolic system just becomes more flexible and efficient.
Okay, so that's the proven column. What's still firmly in the promising but not yet proven column for us humans?
Longevity itself, living longer. We have the biological reason, that autophagy we talked about, and the strong animal data, but we just can't say yet that a TAF will definitely slow your aging or lower your cancer risk over, say, a 20-year span. Those studies are either still happening or just aren't possible yet.
Okay, let's shift from the why to the how. If timing is this critical signal, what are the actual schedules that the research points to? This is where it gets really practical for you listening.
The research really highlights 4 main recipes, you could call them. And it's not like you have to pick one and stick with it forever.
Yeah.
Different approaches might work better for different people.
The first two are probably the most common. They fall under time-restricted eating, or TRE. And this is, I'd say, the easiest and safest way for most people to start. The basic idea is just shrinking your eating window each day. So you have the gold standard, just time-restricted eating, where you'd aim for an 8 to 10-hour window. You start eating at 10 a.m., you're done by 6 p.m. Pretty manageable.
And then there's its slightly more aggressive cousin, 16.8 fasting. 16 hours of fasting, 8 hours of eating. This is probably the most studied pattern because it's still pretty easy to follow. You just skip breakfast and start eating around noon.
Then you have the more intensive styles, the ones that aren't a daily thing,
Yeah.
like the 5.2 method.
Right. The 5.2 method is where you eat normally 5 days a week. And then on 2 days that aren't consecutive, you really restrict your calories down to maybe 500 or 600.
And finally, there's just good old-fashioned eating less.
Exactly. Mild caloric restriction, or CR. Simply eating 10 to 20% fewer calories every day without really worrying about the timing. And this is important because a lot of that long-term primate data is based on CR. It proves that eating less in general is a powerful strategy, even if you don't chase that metabolic switch every single day.
It's interesting that all these different patterns basically lead to the same thing, periods of energy deficit. And the research shows this really strong link between IF, TRE, and better cardiometabolic health, especially for people who are already at high risk.
The data is crystal clear on this, especially for anyone with metabolic syndrome or prediabetes. We see consistent weight loss and really significant improvements in blood sugar control. But here's what's fascinating. The benefit isn't always tied to weight loss. There was one study on men with prediabetes that was a real standout. It showed that just by starting time-restricted eating, their insulin sensitivity and their blood pressure improved, even when they didn't lose any weight.
Wow. So the timing itself is doing something powerful, separate from the calorie cutting.
It's profound. It shows that the biological signal from the timing, that activation of the metabolic switch, is enough to improve your health, even if the number on the scale doesn't change.
That's a huge takeaway. And, speaking of history, this isn't new. The practice of restricting food is ancient. It's in every major religion, Ramadan in Islam, Lent in Christianity, Yom Kippur, practices in Buddhism and Hinduism. It is an age-old global tradition.
And that deep history, plus this recent flood of positive science, leads to a really critical question we get a lot. If the short-term science is so solid and the practice is safe for most people, why aren't governments officially endorsing fasting protocols for everyone?
Right. Why isn't this in the National Health Guidelines? That's where we move from the lab into public policy. What are the main roadblocks?
Well, the official hesitation, based on our sources, really boils down to 5 key things. First, and this is the big one, the lack of that strong, multi-decade human data on longevity. Governments need almost total certainty before making a recommendation that affects millions. Second, and this is so important, fasting is not safe for everyone. The risk groups are significant. Anyone with diabetes, a history of eating disorders, women who are pregnant or breastfeeding, people on certain medications. That's a huge group you have to be cautious about.
And then there's the standardization problem. We've seen that even mice respond differently. So the variability across the human population must be enormous.
It is. That individual variance makes a one-size-fits-all guideline impossible. What works for one person might be useless for another.
And then there's the politics of it all.
Oh, absolutely. Fourth is the huge political and cultural sensitivity around food. Any new guideline affects schools, hospitals, the military, entire economies. So those changes are incredibly slow. And finally, you just have to admit the inherent complexity of nutrition science. Public health bodies want to promote simple, safe advice. Mandating a precise 16-hour fasting window for an entire country just isn't simple.
That's such a critical perspective. And it leads to a really important point for you listening. Given everything we've just discussed, if you fall into any of those risk categories or you're on any medication, you have to talk to a doctor before you change your eating patterns this drastically.
Yeah.
It's not optional, it's essential.
Absolutely essential. Individual biology is just too varied.
So, wrapping this all up, what does it mean for you? We've walked through a really fast-moving field. Fasting has proven repeatable short-term wins for your health. It improves metabolic markers, it lowers inflammation, it can help with weight loss. We also see this huge potential for longevity, backed up by strong animal data and biological mechanisms like autophagy. But that final definitive proof for humans is still being built.
The duality is really clear. Proven benefits for your health right now and massive potential for the long term. And just to leave you with one last fascinating detail, something that shows how complex and systemic these effects really are. Look at a recent finding that intermittent fasting might enhance motor coordination in aged mice.
Motor coordination.
They think it's because fasting helps preserve myelin, which is the protective sheath around your nerve cells, so it could have direct benefits for the nervous system. But on the other hand, some research suggests IF might trigger signals between organs that temporarily suppress hair follicle regeneration.
Wait, so better motor skills, but maybe slower hair growth. That contrast really raises a profound question. How deep do the effects of just timing your meals go? Reaching from your brain health all the way down to the regeneration of your skin and nerves.
It suggests that when you eat might be just as biologically significant as what you eat, something to really mull over.